And we are live streaming on YouTube.
Oh, cool.
Hello, anyone who has joined us on YouTube. We will be kicking off in a few minutes.
Cool. I think we can go. Alrighty. Welcome to Devops Melbourne meetup tonight. Today is a special night as we're having people joining us from different parts of the world. So yay, welcome everyone. It's a special day. So today we are collaborating with My DevSecOps community. It's a global community that connects developers and security personnel and people in the DevOps world. Please check out their site and their YouTube channel. Well, the YouTube channel hasn't been added to the slide, but there is a YouTube channel and there is also a Slack workspace to engage with the community. And we among the panelists, we have Sam, who sort of helped us get this whole thing together. And we want to say thank you and have her say a few words.
Thanks so much, Emily. And yeah, really excited to be here. So as Emily said, I help run a community called My DevSecOps. And it does very similar to what you guys do there in Melbourne. We just do a lot of events, even pre-COVID globally, to make sort of DevSec and Ops information more accessible. So we'd love it if you'd like to join us at mydevsecops.io. As Emily mentioned, we have a Slack community, a YouTube channel. We try to bring speakers from all over the world, which hopefully a lot of you have had in this horrible pandemic. Our next speaker is actually next week, and she's from your side of the pond, or the people listening from Australia, Sarah Young from Microsoft. So if you'd like to join us for that, you can find all the information on mydevsecops.io. And if anyone wants to collaborate, get in touch. But I'm just really excited to be here, and thank you so much, Emily.
Awesome. So agenda today, we've already done the first part. Sorry about the attendees because I don't know how they network without speaking to each other, but we'll see how we work it out at the end. The talks for tonight include How to Secure a Build Server by Patrick Debois. I hope I pronounced that correctly. And Achieving Devops Lessons from a Past Project by Natalia. I do not know how to pronounce the second name. Djohari. Then we'll have community marketplaces where people can share things about the community, whether they have jobs to offer, whether they're looking for jobs, or whether they have opportunities, conferences that people can actually attend. Well, we'll have to ask the attendees to sort of post that in the chat, and we'll somehow read it to everybody, and then you'll have a little bit of networking at the end. Yeah, so I think there are a few house rules, not really rules, but regulations. Use chat to engage and post questions during the talk. Speakers can answer them after they've finished speaking or during whenever they give us an opportunity to ask. Yeah, video will be turned off for the audience. And this session is live on YouTube. So yeah, at this point in time, I would like to call upon Patrick to give us his talk.
Sure. Thanks, Emily. And you know, it's nice to see somebody who has a more difficult name than me to pronounce, Natalia. So that's cool. If somebody can give me the sharing permission for the screen, then I can share my screen again. All right. Here we go. Right. So today's my talk is going to be around how secure is your build server. Some of you might know me from starting Devops days and thereby releasing Devops onto the world. These days I kind of work at Sneak, where I look into things like DevSecOps from there. So, but you can find me on Twitter, Patrick Debois. That's where I shot my most research. So you can follow my information there. So the answer we're kind of asking today is, did you build the build you wanted? And it's kind of like a story of trust. It's probably gonna not be immediately clear, but the fact that we're using the internet, downloading stuff, I don't have to tell you that we're actually trusting things that we don't actually think we trust all the time. It's a little bit nerdy, like it's going to be technology, so it's not just procedures and kind of work through. So bear with me if that's not your thing. I think you'll get the gist of what I'm saying. I had a lot of slides, so I had to kind of compress all my slides into this talk. So I used the compression algorithm. So I still have 110 slides left, so I'll blaze through them as fast as I can. And we're covering the delivery from source to production as much as we can. I'm not trying to scare you. I know a lot of the talks will try to do that. I'm just trying to explain things as they are. Don't want to sugarcoat them or blow them up into proportion. We're not going to talk about hardware attacks like changing things of your server, like your chipsets or stuff like that. So we're not going to handle those things. I'm not going to deal with human attacks, like tricking you into doing stuff. Also, not like talking about physical access bypassing, because that's a league on its own to kind of deal with that in your building of security. One specific area I'm not going to cover is key management. I'm going to talk about like securing your line, but I'm not talking about key management in general. And again, there's a lot of things I'm not covering, but it's just like part of the compression algorithm because that's how it works. So not hardening the servers. If you're doing build service, obviously that's a good thing to do. And that's a whole set of different practices that we can do. So a lot of what this talk will be about is about like making sure that when you build your code on your laptop, you start with your code, will actually be delivered in production the way you want it to be delivered. So a large part of it is actually preventing tampering along the way, and then making sure that whatever you're deploying to production has a high degree of security. I'm not going to say it's completely secure because nobody can tell you that, but it's like a high degree of security that you can do. And let's start with the story as the entry point. You have a laptop freshly, you kind of bought it in the store. There's already quite some security features on there. You install encrypted disk, you install the updates, and you kind of start from that point. There's ways that this could be insecure, but let's assume this is the starting point of our journey, a secure laptop to start with for your coding. One of the first part you're actually trying to do is you want to install something. And when you install something on your laptop, because you need your developer environment, part of it will be TLS or certificates or HTTPS or like the chain of trust. And that by itself is kind of trying to overcome that tampering on the network and malicious injections and stuff. but there's definitely a lot of attacks still possible, even if you're using HTTPS. One of the things is that you can hardly have like certificates that are not valid anymore, or get leaked from your certificates authorities. The other one is that, like, even though you might be using certificates and SSL, it might not be secure because if the cipher that you use is kind of outdated and easy to break. So whenever you kind of doing that, you are actually probably are not checking what these things that are downloading are using as a cryptographic system. Given the example of something like Node.js, if Node.js would be accessing the network, it has a lot of ciphers installed by default, but it is targeted to be broadly a default. Some of the actual ciphers are not like secure anymore. But because it's targeting the generic mouse, you want to kind of tune that. And the same thing is happening with Amazon SSL certificates. So, that's something you could look at, like to make sure that you're using the ciphers that you think are most valid on there. And once you kind of have the certificate going, another problem is to kind of know whether the certificates you are using are still valid. The concept that was used was CRLs, which has like a revocation list. So you're using a certificate that was valid at a certain point, but it's not valid anymore. And even though we have a kind of a standard, not a lot of tools are actually using it. So actually, if you're using HTTPS, it might not be secure due to that reason, because it's an old certificate and somebody hijacked it. Again, the levels of encryption, tools like Encrypt make it easier to kind of update the keys quite regularly, but occasionally things still happen, and it happens to the best of them. This is like the Microsoft Teams group that expired an SSL certificate, and it's as recent as February this year. So it's something that needs love and work to be doing. If you take that one step further, even though we have certificates, they're up to date, they're short-lived, we want to see who issued the certificate, but because there actually might be rogue certificates. Facebook has a nice tool for checking certificate transparency monitoring. So every kind of certificate that is created, you can check and you can see who issued it. So that's a nice tool of dealing with that security level. And you might even limit in DNS which certificate authority that you're allowed to use. So if somebody got access to your certificate or is posing as a certificate through to another CA, this can be limited in what is allowed to use. Again, it's like layer and layer and layer of protection. And so far, we're still securing the layer of downloading something securely over HTTPS. So that's already a lot of work. And there's another ball game, like even when we get the whole security layer of SSL covered, there's a problem of tampering with DNS as such. And like my friend Chris Barter says, like everything's a freaking DNS problem and it hasn't been solved. And, even though we're trying very hard with things like DNSSEC, for example, GitHub doesn't have DNSSEC keys available. So that is still a threat. So, if you want to be completely certain that something is downloaded, has the right set, is not tampered with on DNS, we're still a long way from there. Even curl is not honoring currently the DNSSEC settings. And we seem to be moving that we don't even care about DNS, or like the browser are implementing it themselves, which is kind of a weird way. It's like, we can't control the computer, let's control the browser. And we're like in an insane state at that level. And then there's obviously things like if we have the DNS going and we got the certificates going, that people are doing stupid things, like just do a curl pot over the network. And it's amazing how many installers that still say this is the way to install stuff. One way, like an interesting tool is pipe this, that allows you to kind of review what the tool is executing before you pipe it, even if you want to use that something like that. At least it kind of gives you insight on what that tool is downloading or happening when you do the pipe. We're checking the scripts. We have the secure thing. Now whatever we download, we also want to check the checksum on stuff. And if you look at verifying the node checksum, it's pretty annoying thing, like installing GPG and kind of verifying all the signatures. And what blows my mind is that we're not getting better at this low-level security handling, and we're all like excited about securing our applications at a certain level, but these kind of ground levels need our attention as well. Like Brew doesn't really care about GPG, they're just using the checksums. Docker had an issue that I couldn't even find the checksum of the binary that I downloaded, even though there are like simple steps that, or steps that should be simple to use, but we're not there yet. And I don't want to turn this into a rant, but if you want to really get serious about what your security and what you're doing, these are all things that you could take into consideration. And imagine we all downloaded the tools that we need on our laptop and ready to deploy. We did a brew install of our compiler, downloaded packages through Apple. The next thing is, as a developer, is most likely you're going to load some library to code some stuff with. Phys, we're not building code on our own anymore. We're using libraries from the internet and going from there. But there's a couple of trust issues. So even though we might just install a typo, jQuery instead of jQuery, and like good tools kind of start warning you about you're not using a different tool on that. So another thing that these kind of libraries tend to do is they have post-install scripts. And whenever you kind of download the library, quite often they have like system credentials or system access because packages need to be installed on the system. But you kind of need to make sure that whatever scripts they're executing might be as dangerous as just doing the pipe install that I showed earlier. You might, again, look with some tools to the scripts that those kind of packages start executing. And it doesn't matter whether you're using Cocoa Pods or any tool will probably have a way of post-install scripts to verify that. And so far, we kind of still verifying all the libraries to do that. And then you also hope that they didn't change the behavior of the tool. And for people who don't know what this message means is that at a certain point, npm install started showing advertising when you did installs, just for products. And they could have done anything, obviously, but it's a nice reminder to us that saying, well, they can do whatever on your system. You're blindly trusting the package installer from that moment on. While doing the research for the talk, I actually came across, like when you do libraries and you do some research and you look at the things, don't believe the internet. And I'm not going to sound like a fake news thing, but there are shops that allow you to buy GitHub followers. There are shops that allow you to buy fork stars. So all those reasoning, a lot of people are using the library or they have a lot of traction. Make sure you understand why that is actually real instead of being shopped for. And then another kind of point is that we might be installing from GitHub or libraries or package managers. One way of checking things is that we have tools like package proxies, and instead of relying us to check all the packages before we kind of install them on the system, those kind of proxies allow you to scan them before they even get to your laptop. So from a corporate point of view, that's an incredible powerful tool to use. Just make sure that all checking is actually done at the proxy level and not has to be done at the installation on the computer itself. And it might not be important, but if you look at registry for NPM, In China, it's not that obvious that they're not able to use the NPM registry directly. They have like alternatives, and the checksums don't line up. So, things like that might happen if you see that as a production. And to be honest, this slide is overcomplicated. It's how to verify the integrity of even one package. I'm still looking for a good tool that automates the whole thing, that actually checks that, because it's one thing that the installer checks for the checksums, but there's a lot more integrity checks by, has it been signed by the correct person, the tool, and so on. And again, is that from DNS, and all those verifications need to be done. So far, I downloaded a bunch of libraries through hopefully a secure way that I checked along the way. Now we're getting into like your own code. Like, is that secure? And there's a phrase called shift left, or kind of developer first related. It's like fixing things as early as possible in the pipeline. And that includes you, right? Like whatever code you're writing, you might be the source of introducing vulnerabilities in the system as well. There's a lot of vulnerability analysis or packages tools that you can leverage for either dependencies or your own static analysis tools. An interesting book for that is called Your Code as a Crime Scene, to kind of look at like what you're doing in your own thing as a way of looking at your code, that what makes it vulnerable from that perspective. So that's a nice read for those who want to follow up on that. And what's kind of like interesting, they did an experiment to look at somebody's coding style throughout the years, and they can pretty much keep track of who, even though you imagine you kind of submit like several code anonymously, they might be able to track you just by your coding style and see that, because that doesn't change too much on how people work over the years. So, even though you might do that anonymously. And there's luckily more and more for your own code besides the analysis tools. There's tools that start helping you in an automated way or in a assistive way. This tool kind of almost auto comments on your code that you write. So it becomes more of a story that you can read, which is an interesting approach. Detecting issues in your code is not always looking it up in a vulnerability database, but it might also be where is the most frequent accessed class or the God class that you're using in your code, something that might give you a hint on where security issues might arise. There's a blog post by Google, and already in 2011, they had a system that was kind of to predict bugs in your system. And what they did is they analyzed the hotspots in your code that changed quite often. And then they would present that during code reviews, that whenever that class gets touched, people would say, this is a hotspot class, so beware, whatever you're using, this probably needs like special attention during review. And obviously, I can't help you if I have like an exotic language like Folder, which allows you to kind of use folders, and which is a real programming language for those who want to look at that. But overall, the majority of languages is supported. But if you're doing experimental stuff, you're on your own. Again, another assistive way is to inform developers, not only doing the analysis and kind of helping on the review, but even while you're in your kind of IDE, whatever library you add, you show the number of vulnerabilities that you're adding by just adding a line of code. So I think we'll see more of that in the future, kind of tools that assist you and help you readable code, spot the instances, and we're not going to be stuck with linters and code analysis tools only. All right, next phase. We got the code secure. Let's hope so. We got the downloads. We got the libraries. We're ready to push to Git. So you're going to sign your commit, and that kind of helps in making the checksum correct, and it tells you that you kind of did that. Obviously, you need a little bit of work getting your GPG key up, but there's systems like the Git signatures that allow you not to verify only one signature, but it allows you to multi-sign a commit so that multiple people vouch for that commit. So if somebody gets access to one key, other people cannot use it because it has to be multi-signed. So it creates like a redundancy for signing keys, for signing commits there as well. There's some verification tools. I'll not go into that in detail, but the deck is going to be published. And more tools on verifying that, because even though you're pulling the repo and it has all signed commits, it might be somebody else who signed it for you. So you might want to verify that as well. And the whole tampering and checking and security is not only applying for things that are libraries in code, it might also be used for in the front end. Super source integrity is like checksuming the libraries that you download in your browser from a remote location as well. So a lot of it boils down is that you want to make sure that people are signing and committing and so on. They're like separated roles. There's threshold of signatures, like multiple people will sign. I showed you with the SSL that you have to have a good mechanism for revoking tools, potentially offline tools. You want everybody to have their kind of own keys in the system. And these are the design principles for TUF. It's the update framework. It's like a framework that is used for kind of reasoning about these updates and changes to our systems. It is used as a concept applied to things like Docker. So far we said we're going to do libraries in your code like Node.js or Python or whatever, but you're also building the artifacts from your Docker images these days. As a cloud native person, you're also pushing these to the repository. And so Docker Notary allows you to kind of sign your Docker images as well, make them in a checksum, and then when you do a pull, you can verify the signatures before you're just using a random image from the internet as your base image. So we got Docker, we kind of got some code, we're pushing it to Git, but we can extend that to extra things like, because everything's code right now, it doesn't really matter whether you're writing Terraform, it can have like do analysis, it's checked in as text files. It could be your Kubernetes configs that are checked into and that you can check. And you can even say it's not only infrastructure as code or regular code, but also data as code, like whatever credential you're checking in or database in creation schemes, they're all can be checked and they're all part of making a secure application from that. This is an interesting website. It monitors GitHub Live for keys or URLs or passwords in there, and it's like astounding how frequent this updates in the real-time stream. So have a look at that. It's pretty cool stuff. So I told you that we're getting all this stuff, we're signing our commits, and now we're ready to push. One of the things you can secure is that when you push to GitHub, is that you actually verify their public key prints before pushing over SSH to their server. So there's available, because otherwise you might just be pushing to somebody else's GitHub Git repository. One of the interesting things that I found is when you use these keys and they're made public actually on GitHub, at least the public part, even the public part could be used against you, because imagine you can download all the keys from all the GitHub repos of the people, and then there's a technical protocol that allows to verify whether a user actually exists on a remote system. So if you have like a large scanning, that actually implies a security risk. I know that's a little bit of sidestep, but I find it pretty cool. So pushing to something as GitHub might make you think that, like, how do I trust my SaaS? Because I'm pushing to somebody else's system from here on. I'm not doing it on my own laptop. We got a secure network going, but how do I trust my SaaS? And there's an interesting kind of paper on trusting trusts and how far can you do it? And it's almost like a double loop. Can you trust a system that compiles a system that compiles a system, and so on? So you're be throwing an incomplete loop. And a nice example is Volkswagen, which is a tool that detects whether your tests are being run on your CI server and just makes them magically pass. So it shows you, like, in a fun way, almost like a backdoor of somebody pushing and kind of, your tests have passed. Yeah, they're all passed. They're all good. But, we're just past the whole system from here. More and more, the CI systems or the CI services are actually publishing their own images. It's good that they already document the baseline, but still the binary image could have been downloaded from anywhere. So we are still a far way off that we're able to blindly trust those systems as well. On-prem, we can do similar things, like how the things get installed. And one of the things that I see more and more is of those public CI systems is that they're starting to have auditing capabilities in a way that they log whatever action they take, and not just your execution log, but whoever, when the system is spun up, what certificates is used. So auditing makes you this transparency that we kind of discussed before. And then limiting who has access to your build server or system is also found in many of the systems as well, just to make sure that nobody kind of is able to push from those from anywhere to your CI system as well. You can get fancy on AWS using a user agent, where it's even like whoever executes my code even has to have my user agent before they can actually run my code. That's fancy stuff. And one of the things that we take for granted when we push onto a CI system, and our code is pushed, and that nobody has actually get access to that code that we pushed on disk or something. So, we kind of have to believe that all the disks are scrubbed all the time from that perspective. So much like we had the GitHub push and verifying with multiple signature, Gideon is the system that is used to build the Bitcoin core system. And they actually make builds of the system, but they have a consensus build. So they ask for many people to build the same software, and then they verify if everybody hits the same result, and if there's enough quorum for people to build that with the same checksum or with the same result, then they actually approve that that is something new. So it isn't the one build, because if somebody tempered your code while on the build server, it might not be the same system. So imagine you have like multiple CI systems, much you have like multi-cloud systems that will build the same thing, verify against each other to verify whether you're having the same builds. And that brings us to the topic of reproducible builds. And it's not easy, even if you would run the same build over and over again on your laptop, it might produce a different binary. That's because it might contain checksums, specific things over time, so that it's not producible. So Debian put a lot of time in making packages reproducible in a way that whatever binary that is built can be verified by somebody else. But not all systems are able to do that. As of this day, even building Node cannot be verified as a repeatable build. It will be every time different when you build it. So even that, it's hard to verify as a consistent thing. And another problem is the Linux kernel. And there's a recipe for yogurt, because you kind of have to have yogurt to have yogurt in a way. So current state of the Linux kernel is actually that we're not able to reproduce everything from scratch in the Linux kernel, because there's binaries in there that have been built before. So we're building again from that. So going all the way from source as much as we can. But it's like, it's a mess to boot and be really going on. This is we're going to make that completely reproducible, and that's really helpful in automotive sector, that in a way that we can verify the firmware, the kernel, and everything that's been built. Fully bootstrap that from source, a complete computer. We're still far away from that, but we're getting closer. So the checksums, I mentioned that before, verifying that every time when we build something. But sometimes, imagine we can reproduce every build. That has also a downside, because hackers can actually take the checksum and verify what the binary is. So now that we finally got to reproducible builds, we need systems that to randomize the build again once we build it, because then it becomes like less predictable on what the actual system is. Taking that into a step further, even though you might have reproducible builds with the same compiler, what a tool like Bazel is doing, it's not only making the binary reproducible, it's also making the build environment reproducible. So hermetic builds is that the compiler that you use, the linker that you use, they're all the same while installing. So Bazel tries to go further than just your average build or build system, is that it also allows you to specify which tools that you have been using to build something. And that brings us to, with Bazel, you'll potentially be able to almost build like one binary for your whole application into one. And it brings us to the topic of distroless images, where instead of having to include the whole base system, you just build a minimal system with that one binary. So a lot of the vulnerabilities go away by just having a limited set of images run on your system. The whole analysis system of dependencies, build dependencies, your system, it's almost like a bill of material that you can specify. And a lot of people know kind of, the checksum and the dependencies, whether that's your package.json or your gem file lock. But something can go further, is that your bill of material actually contains the steps, how things are built as well. So because that is like Bazel does, it reproduces things there as well. And once you have the whole system of what has been built with what tool, with what library, with what code, you can have a whole pipeline going to production that verifies things at different at different steps in your deployment pipeline. And the nice thing is that it gives you visibility of what is actually going into production there as well. And once we kind of know what is in production, we can have policies in production that say you're not allowed to pull this because it contains a vulnerability. You're not allowed to run these things and start up these containers because they haven't been verified. They're not trusted, and go from there. And even if they are running, there are starting to exist systems that will isolate things like a Kubernetes pod that has been running, wasn't secure. They start to isolate it on a specific node. They free the node from all the other code and kind of make the node tainted until we kind of have an update. So it's like cool stuff. The more metadata you're collecting while securing your stuff, the more we can use that part in production as well. And I'm going to take a breather here because it's kind of, again, there's a lot of things you can verify, and it is by intention that I taking a very broad approach, and that's a lot of steps you need to take. But I don't want to go into the simplistic hello world example where people say, well, yeah, I got this. It's good to know, but be aware that there's a whole world beyond that as well. And a lot of these things will kind of, people will say, well, we need more monitoring, we need more verification, and we kind of need to do this more continuously. What I often hear in DevSecOps is that this mantra like trust but verify, and you you want to trust something, but hey, you need to verify and write more scripts and write more, kind of get faster. But you have to be aware that security, whenever there's a fix going on, like in whatever part of a library or your own code or somebody else's, there's something called a technical lag, and it will take you some delta time to get into a new version and to get that deployed. Sure, we're getting better, but still it's like reviewing, making sure your test pass, making sure you understand the patch. So there's time that needs to be taken into. And then even you might even consider that you might not know of all the things that are insecure. So if the fact that there's no evidence or you don't know that something is not secure, that is not enough, because the sampling cycle we're doing might be too slow at our current pace. One nice approach I've seen from the people from Pivotal is that they acknowledge the fact that you can not always be perfectly patched in production. They have a concept similar to the error budget, but for vulnerabilities. They kind of have a limit number of vulnerabilities you're allowed to have in production, or like waiting for a fix to be applied. And that's just assuming the fact that, or acknowledging the fact that this is reality and the systems are not perfectly patched. This is a sidestep to promise theory, where Mark Burgess talks about that we're not pushing behavior, we're not a push culture, we're relying on a lot of people that make promises like libraries or SaaS systems that will be secure, or Kubernetes, but we can only see them as a promise. We cannot see them as a set in stone SLA. So we should start dealing with the fact that it's only a promise. And even your skill of, I'm a coder is a promise. You might not be, a coder at all, or might not write secure code. So everything has to be seen as a promise from there on. And that brings me to the fact that a lot of the, things that I talked about is like technology, scanning things and making sure, but the fact that technology only amplifies what the humans do. That's kind of my perspective on this. So technology alone is not enough. And I tend to think of a CI system not different than a person. So at a certain point, we kind of have to say it's secure enough. And as long as we're transparent how things are built and we communicate and track what has been done, that's enough from that perspective. John Allspaw put it very well in his experiment, saying, if you would have a system that you manage and you would leave that alone for an hour, will it still run? A lot of people say yes. If you run it for a day, not run it for a day or update it for a day, will it still run? And yeah, people say yes. How about a week? How about a month? And it shows you that at a certain point, the human is actually part of the system, making sure that things stay updated. In the whole workflow, whether you're having a discussion for your pull request, your release discussion, there's humans involved in that perspective. And so you have to ask yourself, with the whole pipeline system and the CI system, are you building confidence that it's a repeatable thing? Or are you actually building the trust when things fail that you can deal with those issues as well? For that, there's an interesting book called The Thin Book of Trust. It has like 4 pillars: sincerity, reliability, competence, and care. Competence is clear. You level up on that, on new skills and learning. Reliability, are you doing the same things over and over again? Or sincerity, you can say, well, I care about security, but I don't really care. And the interesting part is when you look at something like a library, you can kind of map those 4 things, how we look at a library. We might go in technical, that's a lot of the competence, number of tests, the source code, the tech background of the order, that's competence. Reliability is that how often does it release, how many people are active, that's the reliability of a library. Is it sincere? So when somebody does a pull request, or is there a logo? Is there governance in place? Like, how sincere is the library to you? And do you care? The patience with new people learning, the time spent within the community, all about care factors. So even though you might think that selecting a library is a random thing, you're going through the phase of these 4 parts. And actually, it shows you that there's people behind the library that builds up the trust, and not just the code that is building up that trust. And so security wants developers to build up trust by, being considerate about security in their sprint planning, make sure security is part of their definition of done, and they want to get better at security practices. And developers want security to be considerate of priorities on the feature list, and they want to explain the security issues, and it all boils down to that this is a kind of shared responsibility from the humans and the technology. So I'm living with this note that it's like the fact that it's secure is obviously like the one slide in the beginning I could have said it's not secure, but that's the easy part. It's kind of semi-secure. It might be secure enough for you, but I like the way these 4 pillars put a lens on whatever you do during your process and in your build server as well. And part of it, like if you want to be, I'm almost done, like 2 or 3 slides. So is how trustworthy are you becoming as a person? And that's part of DevSecOps, is that what is your part? Well, how is your responsibility in the whole system as a person? And so I think a lot of the transformation, you could think DevSecOps as something that is technology driven, but I still think that it's on the individual level. So thank you for listening and staying with me. It was a long deck. And if you have questions, now's the time.
Okay, thank you for the talk. So I'll read a few questions that have come through the chat. We have one from C. Blake. What would you consider to be the appropriate reaction when a large vendor selling a DevOps consultancy says we are not expecting firewalls to be enabled on the servers?
Well, it's I think that's already a loaded question, because the person who asked this question is obviously has made up his mind that this is the best way to do things. And it might be that the vendor already had another opinion that might not be the best way of securing things because they have other mitigations in place. So it always boils down in whatever situation is to start having the dialogue. And one reason that could be that they don't have the knowledge, so it comes back to competence. It might not be that they have not the budget because you went for the cheapest supplier, and they don't have time for that. But maybe with some good discussions, they're able to provide that. So I think it's easy to think of other people, hey, they don't know what we know, again, on the competence level, and it's a common reaction. But again, enter the dialogue, and if it's clear they don't understand, explain why, but also try to listen to their perspective on why they're not doing it, because they might have a good reason and a different way of tackling the same problem.
Awesome. So I think the question went ahead and said the same thing that also said, what do you mean I can't upload scripts directly from GitHub public repos into your production servers?
Sorry, can you repeat that question?
I'm sorry, I just didn't read this part because I think it was continuing from the first question. The same vendor said, what do you mean I cannot upload scripts directly from GitHub public repos into your production servers?
Yeah, I guess it's the same, right? So it might be an educational thing that they consider this the best way to do, or they might have a good reason. So it's not something I would personally do, of course, but hey, I've learned not to judge people by just saying something and just listen to their arguments. and then listen to their constraints. Because I briefly mentioned promise theory, and they're trying to make a promise to you, and your job is always to make sure not that they keep their promise, because you cannot say that you can make sure that they will keep their promise, but to mitigate the fact that if they can't meet their promise, that you have another system in place. So that might help there.
Yeah, cool. So before we let Hago speak, there is another question from the YouTube chat from Hamid Rasul about installing packages and binaries. We all know that piping the curl output of install scripts and pipe to hash is a potential security hazard. But how can Snyk or any other tool help make it safe?
I think I haven't seen a tool that actually makes that automated in a way that, because the binary you're able to execute, it's hard to verify. When you verify a package, you assume that the script is safe, but if the script actually starts with download something from the internet, you're having to go through a chain of things that you need to verify. And the only way that I've seen is that if you're really concerned on that perspective, that it will require some manual verification. I think what I've seen people do is that they spend the time doing the manual verification, but then they actually kind of zip up or package the installation afterwards. So they kind of do the review and they kind of almost turn it into a known, and then that gets packaged as a known state of the system, or the known files that get installed on the systems. And from there, not everybody has to verify it on every install. But it does require like a manual verification because people can install whatever they want in that way.
Awesome. So for the final question, I think it's from M. Hago, who also wanted to speak. So I'll ask that you be allowed to speak so that you can ask the question.
Hago,
Yep.
Yeah, can you hear me?
Yes.
Yes.
Yeah, all right. Hi, Patrick. Just quick questions. Is there any tools that can allow, that can enable checking the integrity of Docker image after we pull it from Docker registry? Keep in mind, I tried Notary before and it was very complicated. And even our developers doesn't like it because of complexity. So if there is any workaround to do something like this, just we need to check only the checksum for the Docker image. We don't want things more than that. If it is possible, please let me know.
Okay, I think I've seen some people that so there's the Docker trusted registry, right? That allows you to verify it through GPG and the signing. And then the other way that you could do it is that once you install it, is that I think you can export the image as a tarball and kind of checksum that. But the annoying part is that you kind of have to export it from in a consistent way. And I haven't come across the tool, but that would be my guess on how to approach this, is that turning it into a tarball and then verifying the checksum of the tarball, and maybe some people that would publish it in that way instead of going through the Docker Hub that way. So.
Awesome. I hope Hago, you got your question answered. At this point, I'd like to say thank you, Patrick, for giving us this wonderful talk. And yeah, I believe it's now time for Natalia to give us her talk about, sorry, about achieving DevOps, lessons learned from a past project. Natalia?
All right, thanks, Emily. And that was a great talk. Thanks, Patrick, for sharing. So let me try sharing my screen. Cool. Alrighty. So, um, all right. So my name's Natalia Djohari. My background's Indonesian, so that's probably why my name's hard to pronounce for quite a few people. And I'm Sydney-based. It's quite interesting being able to present something like this because I noticed in the chat quite a lot of people are from Melbourne, but I'm in Sydney. And I wanted to talk a little bit about like my journey in like learning DevOps, more so because I'm a software developer and I'm also a consultant from ThoughtWorks. So as a consultant in ThoughtWorks, I've gotten through multiple different stages of like different projects, different problems, and interacting with quite a lot of different people. And it's always kind of nice to share back to the community what has sort of helped me grow to learn. And one of the things that I've sort of learned in my journey is that there's a lot of topics in the dev community that people just can't really agree on. And that's what I kind of want to talk about today is just DevOps and how I've personally gone through it myself. So with DevOps, I've asked quite a few people what they define it as, and everyone seems to have a different definition of it. So one time I've asked someone, and they replied it as, "Oh, I do DevOps in my at work." So it kind of refers to DevOps like as a type of work. But then I've also heard of like I'm the DevOps in my team, so that becomes a bit more of a role. But I've also worked at a client side where DevOps is a particular team in their structure. So everyone seems to have a different definition of it. I'm not here to discuss like which ones is right and which ones are wrong, but I do want to talk about how it impacted my team previously. So the project that I want to talk about before, we dubbed it the KKK project because it was the tech stack was in Kotlin, it was in Kubernetes, and it was Kafka. So we used to joke to ourselves saying like, "Oh, it's the KKK project," and it was quite interesting because everyone in the team has worked with some parts of the tech stack, but not together at the same time. And I want to talk a little bit more about the team because the team was an important part of the first decision we made together. It was a very big team. We had 2 tech leads, 11 devs, and anywhere between 2 to 3 BAs. But for most of the time of the project, it was 2 BAs. And this happened before the pandemic. So, and I wanted to mention that because we were doing remote work before everyone else was doing remote work. We were spread out in Xi'an in China and in Sydney in Australia. So we already had challenges of working with a remote team with time differences before quite a lot of these things happened. And this location problem also impacted one of the first decisions we made together, which is how we split out work. So we had a brilliant idea of, hey, because that most of the business and at that time and that client, the DevOps team was in Sydney, we'll split out the team in terms of having the infra stream and the feature stream. And at that time, it made perfect sense, like because we wanted to work independently in a fast autonomous way, it seems like a brilliant idea. Well, we kind of learned the hard way. It wasn't the best way of decision to make at that time. a lot of the times that in the infra stream side of it, we find that, oh, how come this feature is taking a long time to do? How come the code was implemented that way? Things like that. And and I was a part of the infra stream, so I knew like the problems that the questions we were asking quite a lot. Whereas like in the feature stream, they were asking like, how come the project was set up in a certain way? Why is the pipeline so slow? Why are we using Kotlin? Why are we using Kubernetes? It like a lot of questions in terms of how everything was set up. So even though we considered ourselves as one team, one project, there became this sort of tension of them and us. We were questioning each other. It felt like there was a heavy tension, and we weren't really good at just having a shared space to kind of talk to each other. It's almost like we had a sort of blaming culture to each other. So we tried to do our best to fix it. So every time there was any sort of problem, if there was any sort of concerns in the feature code that was popping up, we would have time for a code review. We'll get around and collect feedback on how the code should be written or any changes it should get. And if there was any any problem on the infrastructure side, we would prioritize cards to help just fix those problems. So like if the pipeline was slow, we prioritize making sure that we're picking up the next task as making sure the pipeline was faster. So we tried to put band-aids on our problems, but none of it was really working in terms of being a team together. The tension was still there. We were cooperating, but it doesn't feel like that them versus us sort of tension was going anywhere. So because of that, we tried another way of approaching this problem. So we came back to that initial decision in the first place and said like, okay, this way of splitting work between the infra stream and the feature stream is not a good idea. Let's go back and just say like, go back to prioritizing work as they come and try to exchange which side was doing what work. So now the Xi'an side would try to pick up some more infrastructure related work, and the Sydney side would try to get more of the feature development work. This was really good because we started sharing perspective. Like it wasn't easy at the very beginning, and especially at the beginning, there was a lot of times where people were just not comfortable in touching the code that they hadn't written themselves. There was almost like an understanding now on why certain decisions were made that way. We were sharing the pain together. So that allowed us to understand and build empathy with each side of the stream. So what we were doing unconsciously was creating a much more safe space for us to discuss ideas and challenge problems as they come. It was still hard at the beginning, but at least we learned how to compromise on some things. This tension was started to become untangled per se. We were all sort of familiar with the phrase that we want to leave the code cleaner than it was before. But that sort of interpretation of it became a much more wider view. So we were all together on the same boat. We were all heading towards the same destination, but now everyone's in charge of just patching up the boat itself, making sure that like it's not just the feature code that we're leaving cleaner by writing tests and such, but we're also making sure that any sort of local development issues, whether it's the pipeline or any sort of infrastructure related problems, everyone was tackling. And if there is any sort of problems with the feature code, we would fix it together. in the end, what really helped us was like keeping an open mind in terms of having to try different sort of approaches to solving the problem. And that relates back to how I approach DevOps now, because it's a one size fits all. So what initially was defined as the problem as DevOps initially on in the team just did not work for us, but we did go back to what the core values are. So for us, that came into quite a few that I mentioned before of sharing perspective, keeping an open mind, sharing the work, creating that empathy and savings in terms of sharing the space, sharing a safe space for everyone to own the decision that they've made. And that's it. Thank you.
Thank you so much, Natalia, for that talk.
All right. So
We actually do have some time. I'm wondering if anybody has any questions. I don't see any in the chat.
I think people would be like they have the same experience. What should we ask?
yeah, I'm
Natalia.
really keen to hear if anyone's gotten their sort of experience with something like this, and if they'd like to share on that.
Yeah, that's the thing with this webinar format. We can't, like, they have to call, they have to say that they want to talk, and then we can allow them to talk. Right, yeah. So yes, Alex, that's exactly right.
I can probably ask a question. So at the beginning of your talk, a little bit at the beginning, you mentioned something about this talk is not about defining what DevOps is, but now considering that you went through this experience and looking at the structures of teams out there, I'll give an example of organizations that we have worked in where we have a DevOps team over here, and then we have people doing the feature development with all this, and they're actually in the same vicinity, but then there's still that separation. Do you feel like the definition of DevOps would actually help teams not have this separation, or it is okay in the long run in the sense that people will still communicate, and that whole process from my laptop to production will not be interrupted?
Yeah, I reckon it's something I've thought about in a few times, like having a definition for DevOps. I think what's most important is the what works for your team and what fits for that particular situation, right? Because like one of the interpretations I've heard of people saying that why they have DevOps as a team was because they are progressing through the stages of what they think is the right solution for their fit. So it's more so of a journey towards being able to communicate more rather than actually just thinking, say, this is our solution to it. It's not that's not the end of the story. There's still more to come, and it's still going back to like making sure that you still revise on that decision that really helps you to grow together. Does that sort of answer your question?
Yeah, it does. Thank you.
I was kind of hoping to have Patrick's opinion on this, like, because since when you observed this thing and you coined the word DevOps and then it became like a buzzword, now everybody just uses it. We have a whole meetup running around that word. So what is your reaction when you see that, like people have different meanings to that word and they have whole DevOps team and dev team is separate, but DevOps team is separate. So like kind of missing the point, right?
Yeah, so historically, I've always went against defining DevOps. And the reason but that might be personal, is that I lived through ITIL, which had like 10 books defining it. Yeah, it's still, people took it the wrong way. And then there was Agile with the manifesto. It was kind of, but turned into we're doing Scrum. And so a lot of the, like, I think at the first DevOps days, people were asking for a definition. The fact that there wasn't a definition allowed it to bring, to have people bring their own perspective, and that it cut much more richer from people doing different things and different approaches. Obviously, the downside of it is that it's not clear for somebody starting and it's not well defined, but I still personally prefer the fact that it's open-ended. There is, however, let's say an industry kind of conversion to what DevOps is, and with you know, not my kind of personal opinion, but for a lot of people, this is the people that are dealing with the deployments and the CI pipeline as such. I know at many events, there's this mantra, if you're having a DevOps team, you're doing it wrong. Again, I'm like nuanced in perspective in a way that we used to have the Agile team, right? And you could have a DevOps team, and it doesn't really matter if you're calling it a separate team. I think these days, with the fact that people think of it as the deployment pipeline team, probably the closer the word platform team, is that what people are expressing? So that's kind of the nuance that people are bringing it. But what the real problem is, if you're having a DevOps team and that closely collaborates with whichever team, then there's not an issue with calling it a DevOps team. It could be honky dory or whatever you kind of name it. There is kind of a skill set involved and a mindset of people collaborating it. But once you start operating like the traditional ops where we've fought against, that wasn't listening to other people, that only had an eye on the infrastructure, and they didn't care about the application running on top of it or the business running on top of it. I see that still quite often. People get all excited about Kubernetes, and that's their abstraction layer and the boundary that they care. Whatever runs on top of that is just annoying for some of people. I don't think naming them the DevOps team or not the DevOps team is going to change their mindset in kind of bring that perspective. I think what gave me a new perspective of, we advocated for a long time that DevOps is about like a very close collaboration, ideally even in the same room or the same building or on the team, parts of that. I've been part of a startup for a couple of years, and we use a lot of external services. And what annoyed me was the fact that if I'm just using external services, I can't ask them to sit next to me, right? And I don't even control what they do. I have no authority. Like, I can't go to my boss and say, well, make these others do something. And that, dawned on me that this is just another collaboration. And the collaboration is actually about, are these teams or services that you use, are they aligned with the goal that you're doing? If they're not aligned, whether they're internal, external, in your team, outside your team, it doesn't matter anymore, like what you name them. But it's that alignment that makes, they care about your value. They care about what you need to achieve, what your business is trying to achieve. And in that perspective, we started swapping in external services in and out, depending on whether they aligned with what we wanted to achieve. And those can be seen as suppliers. Like it was mentioned in one of the questions, like what if it's an outsourcer or an external party providing this information? and it's still a form of collaborating. It's just not under your authority. And so having that defined as something very specific is probably going to make it hard. Keeping it evolved brings much more richness, and I'll probably take over the confusion it makes. But hey, it's like my view on the world. So that's kind of what I've seen over the many years there.
That's really interesting. I'm actually glad you asked that question, Isha. So I think at this point in time, we will get into community marketplaces. So this is the time where we share if we hiring somebody, if we want to hire people, or if we would like, if we're seeking employment, or this is the time where we can actually ask, speak of all these things.
Can we maybe ask like whoever wants to be on the call live as that we just invite them over, so it becomes like an easier conversation?
Yeah, that's actually put nicely. If you want to be live on the call, please raise your hand, or I don't know how this works exactly.
I'm seeing there are many people still there. I wonder if they want to talk. If anybody wants to talk.
I'm actually going to wrap up the live stream on YouTube just in case it's a scary thing to be live on YouTube. So I'm going to actually end the live on YouTube, and then any attendees who would like to now chat about Community Marketplace but don't want to be live on YouTube, don't worry, you're not live.
Yeah.